Okay, we're trying to go over some of the hint for homework, how to model the weekend arrivals. Okay, this is the last part of the your homework assignment, problem 6. So let's look at the original statement. The weekend arrivals, normal arrival during the weekdays, and either an exponential 6 hour per arrival with 15 entities per arrival. And the other one is a normal distribution with a mean of 4 hours and standard deviation 1 hour with 10 entities per arrival. And there's no arrivals during the weekends. So we talk about the concept. Instead of using a fixed batch size, we might want to set up a model level state variable, two of them. One we call the arrival batch A, one we call the arrival batch B. On the weekdays, the arrival batch A and B equals to 15 and 10 respectively. On the weekend, these arrival batches set to 0. Then these come back and forth every 7 days, and so on and so forth. So these two patterns actually switch back and forth every 7 days. And so the first 5 days of the week, we have arrival patterns of 15 and 10. And the next 2 days we have arrival pattern of 0, arrival batches of 0, 0. Then after 2 days, switch back to the weekend arrival rate, and for another 5 days, and so on and so forth. But these two patterns actually intersect. Let me show you the concept right here. The concept is you on the top you have a weekday pattern, which is every 7 days, and in the beginning of a weekday you set the batch sizes equals to 15 and 10 respectively, and every 7 days you do so. And with a distance, it was a difference of 5 days, and the weekend cycle start. The weekend cycle actually start on the 5th days, or the 6th day, depends on, September 1st of 2019. Actually, it's a Sunday. So how do we model that? And let's do that real quick. If you see that September 1st of 2016 is a Sunday, so we should have 1 day in the beginning of the simulation have no arrival, and then the second day of the simulation we start have arrival, and so on and so forth. So this is what we're trying to do. And during the weekend, actually we set the batch size equals to 0, and for that the end of the 5th day. So on the 6th day, actually we starting 6 and 7 days, we start with the setting the batch size, and this cycle also goes through about every 7 days as well. So this is what we call the brown arrow represent the weekend cycle, still a 7-day cycle. Okay, so let's take a look. We have, I will present 3 different alternative or options. I'm start doing these in this presentation. The first method is using a dummy entity, using a source object to generate, initially generate 2 entities with the inter-arrival times of 5 days. Okay, so the first one will be first beginning of the simulation, and the second entity will arrive on the end of the 5th day, so which is the beginning of the 6th day. One of them represent the weekday reset. One represent the weekend reset of the batch sizes. Then we're using a state assignment property on the path. to set the batch size to the proper value, either 15 or 10, or set them to 0 for both sources. So we basically shut down the sources object during the weekend, and we recycle these two entities on the time path for 7 days and travel time, and come back to do this again. So first we're going to illustrate how to do that. Okay. This is based on one of the student in your class, her basic model. There are two sources, and to begin with, I would like to first set up a two state model level state variable called arrival batch 8. Okay. And the other one we'll call this arrival batch B. Initially, the arrival batch A equals to 15. This guy equals this arrival batch B equals to 10. Okay, so we set up AS2, and for since we only wanted to have two entity on the source, I'm going to add a dummy one. We'll call this dummy. Okay, dummy 1 equals to 0 to begin with. Okay, 0 to begin with, and we show you how to use this dummy in a second. And finding an empty space to establish that cycle things. So we're going to have a source to generate arrival, the entity, and this is what we call it week entity. Okay, and this source, I'm generating weak entity in that, and initially we're going to generate a pattern sort of initially for 0. So in the beginning of the simulation, I will generate one entity, and the interarrival time, it just happens to be 6 days. Okay. Days, and maximum arrival is only 2. So I'm going to generate one from the very beginning of the simulation, the other one after at the beginning of the 6 days, which is the early Saturday morning. That's all I wanted to do, and then I'm going to add 2 transfer nodes. Okay, 2 transfer nodes. Just trying to pass 2 different things. Here I have a pass going to the transfer node 1, another pass go to transfer node 2. So this will be a path for the weekdays pattern, and this will be a pass go through the weekend pattern. And then I'm going to link both of them together and putting a time path in between and recycle the whole thing. And this time path will be travel time, cost me 7 days. Coming back. No, so 7 days. So this will rotate 7 days. I'm going to change their color for the visualization purpose. Okay, adding colors for this. The second one, I'm going to change it to red, and the first one I'm going to use in blue, for example. Okay, so I have 2 different symbols. one called 0, one called 1. The blue represent weekday patterns and the entity, and the red one represent the weekend patterns entity. So in the source, so I'm going to do some state assignment. Okay, state assignment. What I'm going to do, the state assignment is, first I'm going to do this dummy once equals to dummy 1 plus 1. Okay, so I increment dummy by 1 and assign that to the pictures as well. So I'm going to add the pictures, model entity pictures equals to the dummy value for the state variable dummy 1 minus 1. So dummy will be equals to 1 or 2, since I only generate 2 entities, and the dummy value will be equals to 1 or 2, and then I assign them to a picture equals to 0 and 1, so we're using dummy 1 minus 1 type of thing. Okay, I'm going to choose this one, the link way. I'm going to forward if dummy 1 equals to if the picture equals to 0, I'm going to go through the weekend node, so weekday node, weekday node. Okay, and transfer node 2, I'm going to turn weekend node, for example. So here, if the picture equals to 0, I'm going to go this direction. So if model entity, oops, sorry, picture equals to 0, I'm going to this direction. Same thing, if model entity picture equals to 1, then I'm going to the weekend. Okay, so we know that in between there's 6 state of differences. Okay, and what I'm going to do is, on the path over here, I'm going to set this pattern. What I'm trying to do is, instead of using a fixed number of arrival batches, I'm going to using the batch arrival batch A for the one source, and using arrival batch B for the other one. So that means initially the arrival A is going to have a batch arrival of 15 and 10, and then when the weekend nodes go in this path, I'm going to assign them to 0. So how do I do that? I'm going to do a state assignment again on entering. For this portion, I'm going to assign the arrival batch equals to 15 and arrival batch B equals to 10 on this weekday portion. Alright, if it's a weekend, I'm going to do the state assignment. I'm going to assign the batches, both batches equal to 0. So arrival batches A equals to 0, and arrival batches B also equals to 0. Okay, both of them equals to 0. So once they both of them equal to 0, we basically shut down this two arrival because the batch size is referring to that model level state variable. And then the entity go through here, recycle back here to 7 days, and do the same thing again. Depends on their picture. Okay, so what I'm going to, for the animation purpose, I'm going to add a two animation status label to see. Okay, this is going to be arrival batches A. You can see that. I'm going to make a copy of these. Arrival batches B. Okay. So you will see those two, and let's start running this. See how it goes. You see that initially they got set to 15 and 10, and this is the first entity coming through here. Okay, coming through here. And after Thursday, Friday, and Saturday. After Saturday, they got set it to 0 right now. So, and the red entity represents the weekend pattern. So this is again confirming the pattern we have. Initially, we generate a week entity and set the batch size equals to 15 and 10. And after 6 days, and we reset them to at the end of the fifth day or sixth day, we set this equals to 0 and 0. So that's how this model works, and wish we can see everything else is the same, and the model entity, the batch sizes, set it to accordingly. So I'm going to using a breakpoint. For example, here, this is my breakpoint, and so I can use fast forward. You can see that initially, and do it again, and you see when the weekend entity showed up, and these two got the batch sizes got reset to 0, and then weekdays pattern come back, and the batch sizes got reset to accordingly. So these are the this is the first option we do for that purpose. Okay, so this is very easy concept of using two separate entities and coming through every 7 days in the pattern, reset the batch sizes back and forth. Each one of the entity has a cycle of 7-day recycle, and this is how the first part is going to be. I'm going to conclude this section for now and talk about second option. Okay. Now we start doing the second options to see. Let's go through this method 2. I'm going to set up a 2 timer elements, and one for the weekend reset, and start with the 0 day or the first day, and in 2019 the September 1st is Sunday, so I should start with the first day after the first day, and then go every 7 days. The other one is start with the 5th day. Is actually the end of the 5th day, was beginning of the 6 days, and then again recycle for every 7 days. And also I'm going to create 2 generic new processes in the processes tab. Okay, one trigger the weekend timer by the weekday timer event. The other and assign the arrival batches equals to 15 and 10 respectively. And the other process is triggered by weekend timer event, then assign the batch sizes equal to 10, equal to 0 both. So now we show you how to do this. To begin with, let's go to the model. Model option 2. What we do is in the definition elements, we're going to do a 2 timer. Okay, first we're going to do so-called weekday timer. Okay, weekday timer. The other one is the weekend timer. Okay, the weekday timer in our case offset, I will say, since the first day is September 1st of 2019 is a Sunday, so I start with this timer after 1 day, which is the second day, which is a Monday, and go through that every 7 days. Okay. Realign. And the weekend timer actually would recycle for the 6 days to begin with, and also trigger this timer every 7 days. Okay, so on the 6 days I start trigger the timer. Actually it should be 7, since the first day is not is a Sunday. So it's after 7 days I trigger the first weekend timer and recycle them after 7 days. So we set these 2 timers accordingly based on the calendar I have right here, starting from this first day, actually the second day of the simulation, which is the beginning of the day 1, and after 1, 2, 3, 4, 5, and Friday is 6, the beginning of the 6th day, which is the 7th day on the beginning of the simulation. So let's do this. Once we set these 2 timers, and going back to create 2 generic process 1. Okay, here we're going to rename this. First one we call it weekday assign weekday batches. Okay, and the other one we're going to rename as weekend batches. Okay, and the weekday batches is triggered by the weekday timer, and weekend batches is triggered by the weekend timer. Okay, and for each one of the process I just have a assign block right here. We call it assign, name this assign batch A on this. Okay, and make a copy assign batch B. By using 2 assign block, each you can do it within 1 with additional rows back here. By using 2 assign blocks so you can visualize what I'm doing. So this will be arrival batches A equals to 15, and this will be arrival batches B equals to 10. All right, and this is what we have. And same thing, we can copy and paste over here. This one will be arrival batches B in that case. But here we have assignment, arrival batches A equals to 0, and arrival batches B equals to 0. Okay, so we have review. We have 2 timer, and each one start with this according day, represent the weekday and the weekend timer, and in the 2 generic process actually, and assigning the batches to the proper quantity. Again, same thing in the source. I using arrival batches A and arrival batches B right here. Okay, arrival batches B right here. So we can use that, and so we can run. Let's do a breakpoint. So each time the weekend showed up, I'm going to have it break. Okay, so I'm going to stop the simulation when they hit this assignment, so I can using fast forward to see that. So you first see this. We got after 6 days, we got the first one assigned. And step one more, you got both of them assigned to 0, and we can do fast forward again. Okay, we can do this back and forth. You see that all the let's do this as well. Point. You see those batch number got set back and forth from 0 to 15 and 10, 0 to 15 and 10, and then you can make sure these are actually right. So here what we can do is we just stop this. We should be 6 day still. Okay, sorry. 6 day. And if I stop this, see what happened. Yeah, this is the beginning of the Saturday. Yes, this is correct. Okay, the beginning of Saturday. And now we go back to have this one break as well, and then we fast forward. You see this is the beginning of the Monday, and we reset these back to 15 and 10. Go one move forward, beginning of the Saturday, we set these two to 0 again, and back and forth, back and forth. Okay, this concludes the second portion of the option of the model. All right, now we try to introduce the third options and the third method, how to do this. And the method 3 is using a so-called arrival rate tables. Actually, we need 2 of them. Set up 2 arrival tables in the data rate table sections. One for model ATVs every 7-day pattern. One for model BTVs for every 7 days pattern as well. Each rate table has 7 intervals with the interval size of 1 day. And put the proper arrival rate for each sources. Okay, arrival rate equal is a little bit different from the inter-arrival time. Actually, is a reciprocal of inter-arrival time in hours. Okay, so that means 6 hours per for inter-arrival time equals to 1/6 arrival per hours. So over the weekend, the arrival rates both set it to 0, and also in the source objects, we set the arrival mode equals to time varied arrival rate table and refer to proper rate tables. So this is what we're going to do. Exercise this. example. So initially we go to the data section, rate tables, okay, rate tables. I'm going to delete this, start from scratch. So rate table section, and click on create a table. We call the rate table A, okay. And this rate table has what? Interval size of 1 day, and total have is 7 days. So 7 days into right time, and all we have to do is filling the proper arrival rate per hours. Like we said, since for the Model A TV is 6 hour per arrival, so arrival rate should be 1/6, so equals to 0.167 roughly. So I'm going to set this up. So these are actually the first one will be 0 and like that, because the first simulation day will be Sunday and then Monday through Friday afterward. All right, so now we start doing the next table. We'll call it arrival rate table B. Again, each interval size is 1 day, and total only 7 interval. And this one I have a 4 hours per arrival. That means a quarter arrival per day. So this is 0.25. 0.25. 0.25 per arrival. This one should be 0 again, like we had it before. Okay, once we set up these two arrival table, which is the reciprocal of inter-arrival time, we go back to the source. Okay, we don't need this arrival batches anymore. Go back to the source, putting the arrival batches to their prospective arrival batches, 10 and 15. However, in the arrival mode section, instead of doing inter-arrival time, now I'm using a time variant arrival rate table, choosing A for the first source and choosing B for the table B for the second arrival rate. And that's it, and that's all we have to do for this. And then we can run this. You see that in the beginning of the simulation there's no arrival, it's basically dry runs, and after that we start getting arrival. Okay, Thursday now. Friday. And start Saturday, there's no arrival going on. So this gradually inspection station will be deteriorated and move on, and so on and so forth. So this is the third option for modeling the weekend arrival pattern using the built-in so-called feature for the SIMIO, so-called time varied arrival rate patterns. Okay, I'm going to conclude this section.